Previously, we defined partial derivatives for functions of two variables in terms of limits. The partial derivatives of functions of three variables are also defined in a similar way, and in fact, for functions of any number of variables, the partial derivatives are defined pretty much the same way. So I'm not gonna write down these limit definitions for functions of three variables, but let's do an example. Let's say that I have the function f of xyz equal to e to the xy times ln of z. So this is a function of three variables, and I want to find the partial derivative of f with respect to z and x. Now, when we take the partial derivative of f with respect to z, we will assume that x and y are fixed constants. So then e to the xy would be a fixed constant. So then the derivative of this guy would be the constant factor e to the xy multiplied by the derivative of ln of z, which is 1 over z. So that's the partial derivative of f with respect to z. Now, what's the partial derivative of f with respect to x? Well then, with respect to x, we are going to assume that y is a fixed constant and z is a fixed constant. So if we assume z is a fixed constant, then ln of z would be a fixed constant. So y is a fixed constant, ln of z is a fixed constant now. So then the derivative of this with respect to x would be the fixed constant factor ln of z multiplied by the derivative of e to the xy with respect to x, assuming that y is a fixed constant. And then the derivative here would be e to the xy multiplied by the derivative of the exponent, and the derivative of the exponent with respect to x is the constant factor y. So we get ln of z multiplied by y e to the xy. If we have a function of four variables, so let's say f of x1, x2, x3, x4 is equal to x1 squared plus x2 squared plus x3 squared plus x4 squared, then the partial derivative of f with respect to x4 is equal to 2 times x4, because all the other terms will be assumed to be fixed constants when we take the derivative with respect to x4. So we end up with just 2x4. Okay, so I'll stop here. In the next video, we will be looking at higher order partial derivatives, mixed partials or repeated partials.